Hi everyone, today we're going to study population growth, dash doubling time. This is an application of exponential functions. First, let us define population growth. The population growth is the rate at which the number of individuals in a population increases in a given time period. Doubling time is the specific time that the population becomes doubled. We're going to use this formula. Capital P equals capital P sub 0 times 2 raised to the fractional exponent, where the numerator is t, divided by d, where this capital P is the population at time t. P sub 0 equals initial population. 2 here is a constant, and the d is the doubling time. The t is the time given in the problem. Let's have this example 1. A population of mice doubles every 6 months. If it started with 4 mice, how many will there be after 4 years? For our solution, first let us write our formula, and then let us collect the given in the problem. First is the doubling time, and that is d, and it is equal to 6 months. Next is the initial population, and that is P sub 0, and we have here 4. Next is the time, denoted by t, which is equal to 4 years. Now let us make sure that the doubling time and the time given in the problem are of the same units. See, our doubling time is given in months. Let us convert this given time as years into months. And we know that in 1 year there are 12 months. So let us multiply these 4 years times 12. We will get this 48 months. We can see now that the doubling time is given in months, and the time t is now in months measured. Next, let us write our formula, and then let us substitute the corresponding values. The P sub 0 is now substituted by 4. The constant 2 is there. The t as numerator becomes 48 over d, and d is our 6 months. And then let us simplify our fraction. 48 over 6 becomes 8. So we have now our line here as 4 times 2 raised to 8. Simplifying 2 raised to 8 is 256. And the product of 4 and 256 is 1024. Number of mice after 4 years. This is our final answer. Let's have example 2. A biologist is observing the growth pattern of a virus. She starts with 50 of the virus, and the constant doubling time of growth is 8 hours. How many virus are there after 1 day? For our solution, let's begin with our formula. And it's now written here. Let us now write the given of the problem. First is the initial population. P sub 0 equals 50. There are 50 virus. Next is the doubling time denoted by D, and this is 8 hours. And for our T, it is written here 1 day. Again, let us check and make sure that the doubling time and the given time of the problem must be on the same measure. Our doubling time is in hours, and the time here is given in day. Let us convert this day into hours, since we know that there are 24 hours in 1 day. So we will write here 1 day equals 24 hours. And we will use this value 24 in our formula. Let us solve now the problem using our formula. So it is now written here again. And let us do the substitution respectively. The P sub 0 is now 50. The constant 2 is there. In the fractional exponent, our T is 24 over D, and the D is 8. Simplifying our fractional exponent power, this 24 over 8 is equal to 3. So we have here 50 times 2 cubed. And this 2 cubed is simplified into 8. Then we will get the product of 50 and 8. So we have here P equals 400. And this is our population of the virus after 1 day. This is our final answer. Hi everyone. Today we're going to study half-life decay model. This is an application of exponential and logarithmic functions. For half-life decay model, given an organism is represented by this circle, and the organism decays into half given a certain time. We have a formula which is A equals A sub 0 times 2 raised to negative of fraction T over H, where A is the amount of organism at time T. This A sub 0 is the amount of organism at time T equals 0. The H is the half-life of the organism, and this is given in the problem. The T is the time that corresponds to A, and this is the A. Let us have example 1. The initial mass of an iodine isotope was 200 grams. Determine the iodine mass after 30 days if the half-life of the isotope is 8 days. First, let us collect the given. The A sub 0 equals 200 grams. The H equals 8 days. And the T equals 30 days. Then let us write the formula. A equals A sub 0 times 2 raised to negative T over H. Let us now substitute the values. The a sub 0 is now 200. The 2 is a constant. The negative t, which is 30, divided by the h, which is 8. Let us simplify the fraction. We have this 30 divided by 8 is 3.75. So the exponent is negative 3.75. To simplify further, this value is equal to 0.07433. We'll just copy the 200 down here. Then we will take the product, and the answer is 14.87. This is the iodine mass after 30 days. Now, for a quick computation using calculator, from this equation, we can use our calculator and put this data. First is the 200 times 2, then the symbol raised to, open parenthesis, then negative 30 divided by 8, then close parenthesis. Then we hit the equal sign and the answer will come, the 14.87. So this is our final answer. Example 2. The half-life of plutonium-241 is 3 years. How much of an initial 2-gram sample will remain after 5 years? Let us first collect the given. The a sub 0 equals 2 grams. The h, or the half-life, equals 3 years. And the t is equal to 5 years. Then let us write our formula. Then we will substitute now the values. So a equals, the a sub 0 becomes 2 times the constant 2 raised to the fraction negative. The t becomes 5 divided by h becomes 3. Then we will simplify further. This negative 5 over 3 is equal to negative 1.66667. Then we will simplify this part. We will get the value 0.31498. We will get the product of this decimal and the number 2, and we will get 0.63. And this is the amount of plutonium-241. Of course, we will not forget the unit of measurement, and that is the gram. So for our quick computation using calculator, from this part of the computation, we can write 2 times 2, the symbol raised, and then open parenthesis, negative 5 divided by 3, and close parenthesis. Then hit the equal sign, and you will get the value 0.63. This is our final answer. Hi everyone. Today we're going to study exponential growth and decay. This is an application of exponential functions. Exponential growth is typically seen in the growth of populations of humans or animals or bacteria. For an original amount denoted by A sub O that grows or decays at a rate R for a certain time denoted by T, the final amount, capital A, is computed by this formula. Capital A equals capital A sub O times the constant E raised to a power that is a product of R and T. Let us have this example 1. Chris is a researcher at the Center for Disease Control and Prevention, and he is trying to understand the behavior of a new and dangerous virus. He starts his experiment with 100 of the virus that grows at a rate of 25% per hour. He will check on the virus in 24 hours. How many viruses will he find? First, let us write our formula, and then let us list the given. Let us begin with the original amount, A sub O, and that is equal to 100. Next is the rate R, which is equal to 25% per hour. Let us convert this 25% into decimal. Let us divide this 25 by 100 and dropping that percent sign, and this 25 over 100 equals 0.25. Then the next is the time denoted by T, and this is 24 hours. Please take note that the rate and the time must be of the same unit of measurement. You see here, the rate is with respect to hour, and our time is 24 hours. So we verified now that they are the same. If they are not the same, you need to do some manipulation for this unit of measurement for time to conform with our rate. And then, let's go now to our computation. Using our formula here, let us do the substitution. So our A equals A sub O times E raised to the product RT. A sub O is now substituted by 100. E is a constant. Our R is the 0.25 and the T is 24. Let us simplify the product. We will have 0.25 times 24 is 6. So we have now in this line A equals 100 times E raised to 6. We will use our calculator to simplify this E raised to 6, and we will get this 403.43. Then times 100, we will get the answer 40,342.88. Let us round this off to whole number, so we have 40,343. And this is our final answer. Let's see this example 2. Radon does 222 decays at a continuous rate of 17.3% per day. How much will 100 milligram of radon does 222 decay in 3 days? Let us begin our solution by writing the formula. Let us enumerate the given in the problem. First is the original amount. This is A sub O equals 100 milligram. Next is the rate. And we're going to write here negative 17.3% because of the word decays. And let us convert this percent into decimal. First, let us divide 17.3 over 100. The negative sign is still affixed, and we will have the final decimal as negative 0.173. Next is the time, denoted by T, and this is equal to 3. Let us check again that the units of measurements for the rate and the time must be the same. So the rate is per day and our time is 3 days. So we are sure that they are the same. We can now proceed with our computation. Listing again our formula, and let us do the substitution. Our A sub O is now changed into 100. The E is a constant. Our R is now negative 0.173 multiplied by T, and our T is 3. Let us simplify our power. Let us get the product of this negative 0.173 and 3. We will have this negative 0.519. Let us use our calculator to simplify this constant, e raised to negative 0.519. And we will get this 0.595115. Getting the product of this decimal and 100, we will get this 59.5115. And this is the final amount in milligram of radon-222 that will remain after 3 days. This is our final answer. Let us see this example 3, and this is calculating continuous growth. A person invested $1,000 in an account earning a nominal 10% per year compounded continuously. How much was in the account at the end of 1 year? Let us write our formula. Then let us list the given starting from the original amount. A sub O equals $1,000, followed by the rate denoted by R, and this is 10%. Converting our 10% into decimal, so we have 10 over 100, and this is equal to 0.1. Next is the time T, and this is equal to 1 year. So let us check again if our rate and the time are of the same unit of measurement. Our rate is 10% per year and the time is 1 year. So they are the same. We will now proceed with our computation. Listing our formula again, it is now here, and let us do the substitution. A sub O is now 1,000. E is a constant, we'll just copy. R is now 0.1 times T, the time is 1. The 0.1 times 1 is simply 0.1. We will use our calculator to simplify the constant E raised to 0.1. And this is 1.1051. this decimal multiplied by 1000, we will get 1105.1. And this is in dollars. This is the final amount at the end of 1 year. This is our final answer. I hope you learned something from this video. See you again next time.